Today we are going to learn about advanced techniques in Seaborn Heatmap Customization. We'll explore how to enhance your heat maps using advanced features in Seaborn, focusing on customization to improve clarity and analytical impact. Welcome to our session on advanced techniques in Seaborn Heatmap Customization. Seaborn is a powerful Python library for statistical data visualization, essential for creating informative and attractive graphics. Heat maps are among the most effective ways to visualize matrix-like data, often used to show patterns, correlations, or just raw data. Customizing these heat maps is crucial for tailoring visualizations to specific analytical needs, enhancing both clarity and impact. In this video, we'll start with a quick review of the basic features of Seaborn Heatmaps, laying the groundwork for the advanced techniques we'll explore. By the end of this session, you'll be equipped with the skills to make your data visualizations more insightful and impactful.
Before diving into advanced customization, let's quickly review how to create a basic heat map in Seaborn. The core function you'll use is sns.heatmap, which requires a dataset structured in a matrix form, such as a data frame. Seaborn provides several built-in color palettes like viridis and plasma that can be applied to your heat map using the Heatmap parameter. Annotating your heat map is a simple, yet powerful way to add clarity, achieved by setting the onNode parameter to true. This will display the data value in each cell. Adjusting the figure size and aspect ratio can be done using the figure size parameter within matplotlib's plt.figure, allowing you to tailor the display to fit more data or highlight specific areas. Understanding these basics sets the foundation for more complex customizations that we'll explore next.
Color mapping is a powerful tool to enhance the interpretability of heat maps. In Seaborn, you can customize color palettes beyond the built-in options. By using the sns.color_palette function or directly passing a list of colors to the Heatmap parameter, you can create a palette that fits your data's narrative. Deciding between continuous and discrete color maps is crucial. Continuous maps are suitable for data with a gradient, while discrete maps work well for categorical data. Diverging color maps are particularly useful when your data has a meaningful midpoint, like 0 in financial data, allowing you to highlight differences above and below this point. Implementing color thresholds can also guide the viewer's attention to significant data ranges, achieved by setting the min and vmax parameters. High contrast between adjacent colors can greatly enhance readability, ensuring that even subtle differences are easily distinguishable.
Integrating hierarchical clustering with heat maps adds another layer of insight by organizing data based on similarity. Hierarchical clustering groups data into clusters, which can then be visualized alongside a heat map. In Seaborn, this is typically achieved using the cluster map function, which automatically creates a dendrogram, a tree-like diagram showing the arrangement of clusters. This visual organization helps in identifying patterns and relationships within the data that are not immediately visible. Key parameters like method, metric, and z_score allow you to customize the clustering process. For instance, choosing between methods like single or complete affects how clusters are defined, while different distance metrics, for example, Euclidean, city block, determine how similarity is measured. Effectively visualizing these clusters highlights the structure within your data, making complex datasets more interpretable. Masks in heat maps are useful for focusing on specific data points, allowing you to highlight or obscure parts of your data. This technique is particularly helpful when you want to draw attention to outliers or specific ranges without overwhelming the viewer with all data points. In Seaborn, masks can be created using Boolean arrays where true values represent data points to be masked. This is passed to the mask parameter in the sns.heatmap function. By strategically masking data, you can direct viewers' attention to areas of interest. Combining masks with annotations further enhances clarity, providing context to the highlighted data. For example, in financial data analysis, masking can be used to focus on significant deviations in stock prices, making it easier to communicate findings. This technique is invaluable for presentations or reports where clear and concise data visualization is necessary.
Dynamic scaling of data values is crucial for creating heat maps that accurately represent the underlying data. This process involves adjusting the scale of data values to fit within a specified range, enhancing the heat map's readability. One common method is normalization, which rescales data to a range of 0 to 1. This can be achieved using the norm parameter in Seaborn, allowing for more consistent color mapping across different datasets. Adjusting color intensity using parameters like min and vmax can also help in highlighting subtle differences within your data. It's important to balance the representation to avoid misinterpretation, ensuring that significant data points are neither understated nor exaggerated. By applying dynamic scaling, your heat maps will more accurately communicate the nuances of your data, providing viewers with a clearer understanding of the information presented.
Combining heat maps with other Seaborn plots can provide a comprehensive view of your data, enhancing the storytelling aspect of your analysis. Seaborn's pair grid or facet grid functions enable the creation of complex multi-plot grids, allowing you to juxtapose heat maps with other plot types like scatter plots or bar charts. This combination can reveal relationships between variables that a single plot might overlook. Pair plots, for example, are effective for visualizing pairwise relationships in a dataset and can be combined with heat maps to add a layer of depth. Overlaying line plots on top of heat maps can highlight trends or patterns across time series data. This integrated approach not only enriches the visualization but also provides a richer context for interpreting the data, making your analysis more engaging and informative.
Interactive elements in heat maps can significantly enhance user engagement by allowing viewers to explore data dynamically. While Seaborn itself is static, combining it with interactive libraries like Plotly can bring your heat maps to life. Plotly offers features like hover to display additional data details and zoom to focus on specific areas. Implementing these features involves converting Seaborn plots to Plotly objects using the plotly.figure_factory.create_annotated_heatmap function. This transition allows for a more immersive experience, where users can interact with the data to uncover deeper insights. The ability to explore data interactively is particularly valuable in presentations or online dashboards, where user engagement is key. By leveraging interactivity, you can make complex data more accessible and engaging for your audience.
To appreciate the practical applications of advanced heat map customization, let's explore some real-world case studies. In healthcare, heat maps are used to analyze patient data, identifying trends in symptom occurrence or treatment outcomes. For instance, a hospital might use heat maps to visualize the correlation between patient recovery times and treatment types, facilitating data-driven decision-making. In the financial sector, heat maps help in tracking market trends, with companies using them to analyze stock performance or economic indicators over time. A case study might involve visualizing the volatility of stock prices across different sectors to guide investment strategies. In retail, heat maps are employed to understand customer behavior, such as tracking foot traffic in stores or analyzing online purchase patterns. These case studies highlight the versatility of heat maps in various industries and demonstrate how advanced customization can enhance the insights derived from data. By learning from these examples, you can apply best practices to your own data visualizations, improving both clarity and impact.
In conclusion, we've explored a range of advanced techniques for customizing Seaborn heat maps, from color mapping and hierarchical clustering to dynamic scaling and interactive features. Customization is not just about aesthetics, it's about enhancing the clarity and impact of your data visualizations. By tailoring heat maps to your specific analytical needs, you can communicate more detailed insights effectively. I encourage you to experiment with these techniques, applying them to your own datasets to discover new patterns and stories. For further learning, consider exploring Seaborn's extensive documentation and community resources. Thank you for joining us in this deep dive into Seaborn Heatmap customization, and happy visualizing.